Megan told me to tell you happy birthday.
Thank you. Thank you. So anyway, yes, in case I did not decorate myself, just so you know. I don't love myself that much. My AP students came in and decorated and had a cake, and it was a very nice surprise to come in at 7:15 in the morning and see this. Of course, I'm really more interested in if they're going to clean it up, because I really don't want to. I think that would be the better birthday surprise. But anyway, given the formula, write the name. The first question you ask yourself is, are there prefixes in the name? Give me an example of a prefix. Mon, di, tri, tetra, penta, hexa, octa, nona, deca, right? Prefixes like that, okay? If the answer is yes, it is easy peasy lemon squeezy. Which, by the way, does this name have prefixes in it? No. Okay, so you wouldn't follow these rules for this one. But if it is yes, it's only, remember when we used the prefixes? Do you remember? Non-metal, non-metal. That's it. That's it. So you would write the symbol for the first non-metal. And then the prefix becomes the subscript. That's why you have to know your prefixes. But again, remember, you only have to memorize the first 4, because 5 through 10 are in table P. Okay? Then you write the symbol for the second element, and the prefix becomes the subscript. Because that's the only time you're going to have prefixes. You don't look up any charges. You don't do any crisscrossing, no switcheroo, nothing. Okay? So if I gave you something like dioxygen tetranitride, okay, say that was the name, okay? Then I write the symbol for the first element, which is oxygen O. The prefix becomes a subscript. Di means 2O2, okay? Nitride is the element nitrogen. Tetra is 4, okay? O2 and 4, okay? That's it. That's all you do. So the prefix name is super easy. It's when it doesn't have prefixes that kids have problems, like this one. If it doesn't have prefixes, the first thing you want to see is, do you have a polyatomic? So you want to check table E for polyatomics. A little hint for that, I call polyatomics PAs. A little hint for that is most definitely if the name does not end in I. So if it ends in ate, ATE, or ITE, then you definitely have a polyatomic, okay? But if it ends in I, you can still have a polyatomic, because there are 2 polyatomics that end in I. Hi, Crystal. Names are over there. Hold on. Pages are here. We're talking about formula writing, okay? Hydroxide is a polyatomic, and cyanide is a polyatomic. But anyway, when I say check table E for polyatomics, I mean go on here and go, okay, what do I have? Tin, and what was the other one? Fluoride. So I'm going to check here. Is tin a name? No. Is fluoride a name? No. Okay? If they were, I would write down the symbols and look up the charges and all that, okay? But you want to see if you have a polyatomic. If there is a polyatomic, you write down the symbols and charges. Or more, you might find 2. If there are no polyatomics, then it's just element symbols. Whoops. Whoa. Hello. What letter is that? No polyatomics. Whoops. Then write element symbols. Now, here's the thing. With these compounds, they have to be neutral. So after you write down the symbols, then you have to write down their charges. Okay? Look up their charges. And if the charges don't equal 0, crisscross. criss-cross. And I'll explain that because if you don't know what I'm talking about, that's going to be a little bit confusing. This is sort of annoying too. Okay. So if we have this compound up here, which does not have prefixes, I'll put that back up if you'd like. Okay, we check the table E for polyatomics, it's not on there. So we write down the element symbols. So we need the symbol for tin, and we need the symbol for fluoride. If you don't know the symbols, they're in table S as in Sam. You could just look them up there. Does anybody know the symbol for tin? That's a hard one. SN. Good. Sid? Okay, tin is SN. Because it's from the Latin word stannus. Not every word comes from English, right? Not every symbol comes from English. Don't be self-centered. So stannus, tin, SN, right? Now, we don't have to look up the charge on tin because it's right there. The number in Roman numerals is the charge on your metal. So this is tin plus 2. Now, fluoride. What's fluoride symbol? F. We go and look up its charge in the reference tables. And if you notice, there's only one. Now, if it were another nonmetal, like chloride, and there were a whole bunch, remember you have to pick the negative for the nonmetal? The metal is always positive, the nonmetal is always negative. So we write down F's charge, -1. Do those charges total 0? No. They have to. So you criss-cross. You will need 1 tin and 2 F's. Because if you have one thing that's +2 and 2 things that are each -1, they add up to 0. So the formula for tin 2 fluoride is SnF2. Yay? All right, I'm going to give you a couple. I know. Here we go. 3. I'll give you 3, okay? Here they are. I want you to please write the formula for calcium phosphate, sodium oxide, and carbon tetrafluoride. Okay, so the way I do it, you can do it this way or not. I draw a wall where my arrow is because the idea is to make what's on the left equal what's on the right. Every capital letter is a new element. So I list my capital letters on the left. I have K. I have CL. That's CL, not I. It will never be CI. Okay? And O. If you, when in doubt, on a Regents exam, you're not sure, you raise your hand and ask. Okay? Because we can tell you that. We can't give you answers, but we can tell you that. I copied that list on the same order over here. K, CL, O. Okay? Now you count. The total number of atoms is equal to the coefficient, which is the big number here, times the little number, which is the subscript. Okay? So how many K's are on the left? 1. And CL's? 1. And O's? 3. Good. This 3 only goes for the O. It doesn't go for everybody. You'll know if it goes for everybody because, for example, this, it will be outside the parentheses. So this 2 would get distributed to everybody inside the parentheses. So if I'm counting P's, this is 2 P's and 8 O's. Okay? You distribute this, so 2 times 4. Okay? So the subscript only goes to the things inside the parentheses. If there are no parentheses, it only goes to that individual element. Okay? And now we go to the other side and do the same thing. You should have 1 and 1 and 2, correct? Okay. Now, balancing, there's no secrets, though I have a couple tricks that I'll share with you to help you. You pick somebody that is not equal. Right now, mass is not conserved. Where the heck did the other oxygen go? It cannot disappear. So we need to make it right, okay? And the only thing you can do is add or change one of these guys. You can only add or change coefficients. That's it, okay? You can't change subscripts because then now it's not neutral and you just screwed up the compound. Okay, it's no longer the compound you thought. So, You pick somebody that's not equal that will be easy to make equal. Right now, I don't really think there's anybody that's easy to make equal. How do you turn 2 into 3? Well, you might know. That's one trick. Does anybody know what you can multiply 2 by to give you 3? Yeah? 1.5. See, but most people don't think like that, right? So what you could do, Dylan, because you got halves, is you could put a 1.5 here. Okay, don't do this right now. Just watch me. But you can't, and that would make this 3 and then everybody's balanced. But it's impossible to have 1.5 molecules. So what you'd have to do then is get rid of that half by multiplying then all the coefficients by 2. So this would be 3, 2, 2. Okay? Now, for most of us, here's another trick that, and I would only do this when the oxygens are not funky, and I'll explain what that means in a minute. They're only one compound. You can think of least common multiple. Well, I don't know how to turn 2 into 3 or 3 into 2, but I can make them the least common multiple of 3 and 2, which is 6. So I know how to turn 2 into 6, and I know how to turn 3 into 6. So let's make 6 oxygens on both sides, right? Okay, now you might think least common multiple. So that would mean we need a 3 here and a 2 here, right? Because then 2 times 3, 3 times 2, that would give you 6 oxygens. But remember, when you did this, you screwed up the K's and the Cl's that were balanced. Don't worry, you can fix them. So distribute. 2 times 1 gives you 2, 2 times 1 gives you 2. And then go back and fix your K's and your Cl's by putting a 2 here. 2, 2. Okay? Now the other thing I will say is if you don't get least common multiple, and some of us don't, it's okay. 90% of the time, these equations can be balanced by putting a 2 in front of the first compound in the formula. So let me just take you back a minute. Remember, we're going to rewind and go back in time to where this was this. 1, 1, 3, right? And this was 1, 1, 2. And say, oh my God, I have no idea where to start. You know what you do? Stick a 2 here. These equations that they give, now this will not work in college. Don't try. My teacher told me to put a 2 in front of the first thing and I'd always get it to balance. No, and it won't even always work at this level, but I will tell you, somewhere around, I don't know, 80, 90% of the time, this will work. So when in doubt, if the place to start is not evident, and this is confusing to you and you don't know where to go, stick this 2 here, make the changes, distribute it to everybody in the compound, because that means you have KClO3 twice. That's what that 2 means. You have 2 of those compounds. So 2 times 1K gives you 2, 2 times 1Cl gives you 2, and 2 times 3 O's gives you 6. And now try to balance it from there. How can you get 2 K's over here? Put a 2 in front. 2 times 1K gives you 2. 2 times 1Cl gives you 2. K's and Cl's are balanced. Now I need 6 O's, because there's 6 O's over there. How do I get 6 O's over here? Put a 3. 3 times 2 gives you 6. And much of the time, not always, but much of the time that will work. Okay? There's a name for this kind of reaction that you should know. Does anybody know what this type of reaction is called? Yes. Beautiful. Decomposition. It's like divorce, right? The compound is breaking apart. This is divorce. Okay? Decomposition is the name of that reaction. You have to know that. Okay? That's why I figured I'd bring it up. Look at, let's balance another one. Let's do 69. It's a little crazier, right? All right, first thing they want us to do is balance it. I wish there were harder ones. These are all pretty straightforward, but we will draw a wall and list our elements and count. Ooh. That's one. We'll do that one next. Okay? So draw a wall. Let's list our elements. Why don't you try to list and count, and we'll see if you counted right. Because that's sort of the first step, is if you don't count right? So list and count, go. Don't look at my answers up here. Okay, when you get to this side, you got some funky stuff happening. Funky. I told you I would define it. Do you see carbons in two different compounds on the same side of the equation? So I just don't write down 3. Even though I know there's 3 carbons on that side. I write down there are 2 in the first compound, plus there is 1 in the second compound for a total of 3. You might go, well, what's the big deal? Why does she care if I put 3 down or I list 2 plus 1? Everybody knows 2 plus 1 is 3. Because when you start making changes, if you just had a 3 there and I put a 2 there, you're going to think 2 times 3 and write 6. But you don't have 6. You would have 5 if I put a 2 there. So list them separately. And then as you add coefficients, just change the one that you added the coefficient to. So this is what I call funky. And you should never start by balancing funky. Funky should be balanced last. Everybody else first, and then the crazy ones. Okay? H's. Now, you might go, do I do 5 plus 1? Nah, they're in the same compound. I could just put the total, 6. But when they're in different compounds, I list them separately. O is funky, right? I'm going to do 1 in the first plus 2 in the second for a total of 3. Okay? Now, this is a little bit crazier. This is definitely a higher level than the last one. Pick somebody easy to balance. Who up there is the easiest one to balance? H. How can I get 12 H's on the right-hand side of the equation? Not divide.
On the right, multiply by 2.
Yeah, because you can't take, the lowest coefficient you can have is 1, right? So you're always adding, and that brings up a good point. You're always adding coefficients to the side that has less atoms, because you can't take them away, okay? Well, if there was a coefficient of 2 and you didn't need it, you could take it away, but you can't make it less than 1. So we would put a coefficient of 2 here, because then, right, there's a total 6. And if you, honestly, if you wanted to write this like this so it was easier for you, you could do that. Okay? You could consolidate the formula. Yes? No? Oh, you're just thinking? Okay, now, what you might be thinking is that didn't just change the H's. And after I put the 2 there, I need to go make some changes in numbers. This 2 gets distributed to everybody in the stinking formula. So I used to have 2 carbons in that first compound, right? 2 times 2 gives me 4 now in the first compound. I'll re-add in a minute. Let me continue to make my changes. I used to have 6 hydrogens. 2 times 6 gives me 12. Yippee. Now I'm balanced with the H's. I don't want to mess with them over there. Okay? And I used to have 1 O in the first compound. 2 times 1 gives me 2. Now, I got to make changes to my totals for my C's and my O's. Because now I have 4 here and 1 there. That's not 3 anymore. That is 5. And now I have 2 there and 2 there. That is 4. Right? Okay. This one's a little bit harder. We definitely don't want to make any changes to this, because then everything we just did to H's is moved. And we definitely don't want to make any changes to this. So I need the total to be 6 carbons over here. Or you could look at the oxygens. It's 6 of one, half dozen of the other. What I really need this 1 to be for carbon is a 2. Right? Because then you see 4 in the first compound. If this were a 2, 4 and 2 would give me 6. Right? So what I need is this number to be 2. How can I get the second number of carbons, the number of carbons in my second compound to be 2? What do I have to do? Hey. Robbie will know. Robbie, they don't know how to get this number of carbons in this compound to be 2. Put a 2 in front of it. There you go. Or maybe you just didn't want to share with me. It's my birthday. You should share. 2 times 1 is 2. I did. I did share my cake. Well, it was gone. You didn't bring in the cake. They brought the cake in. 4 and 2 is 6. And then distribute this to here. There were 2 oxygens. 2 times 2 is 4. 4 and 2 is 6. Done. Balance. What's the name of this reaction? It's an organic reaction. What's the name of this organic reaction?
Oh, I didn't.
Yes! Yes, it's my favorite organic reaction. Fermentation, right? You take the sugar and you decompose it. So if you said decomposition, that would work, but that's not the name of the organic reaction. Into this thing, ethanol, that's an alcohol, and carbon dioxide. That's the process via which alcohol is made. Fermentation, okay? Look at number 15. Try to balance it right now on your own. 15.
50?
1-5.